The story of the rebuilt Bugatti Chiron has taken a dramatic turn, and it has caught the attention of the entire automotive world. What started as a simple rebuild project by Matt Armstrong has now become something much bigger. Recently, Matt revealed something unexpected about the car that raised serious questions about the original damage and how it was handled. According to his findings, there may have been a known weak point in the car's design, specifically in the gearbox mounting bracket. This discovery has made people wonder if Bugatti already knew about this issue before the crash even happened. If that is true, it could completely change how we understand why the car was written off in the first place. Instead of being an unfixable wreck, the Chiron might have suffered from a predictable failure that could have been repaired. This idea has sparked debate among car enthusiasts, engineers, and fans of Matt's work. The situation is no longer just about fixing a damaged hypercar. It has turned into a deeper investigation into how manufacturers handle design flaws, repairs, and control over their vehicles. As the rebuild continues, more details are coming out, and each one adds another layer to this already fascinating story. As Matt continues working on the Chiron, the tone of the project has clearly changed. In the beginning, many people believed this rebuild would be nearly impossible. The car was heavily damaged, and even Bugatti itself suggested that certain procedures, like splitting the car in half, could not be done outside their factory. However, Matt proved those claims wrong. He successfully separated the car and removed all the damaged parts, which was a major achievement on its own. Now, the focus has shifted from taking the car apart to putting it back together, and that is where the real challenge begins. Matt himself has said that disassembly was not as difficult as expected, but rebuilding the car correctly will require much more skill and precision. This stage involves fixing critical components, rebuilding the front structure, and ensuring that everything fits perfectly. At the same time, Matt is not just aiming to restore the car to its original condition. He is also trying to improve it. This mindset shows confidence and ambition, as he is willing to go beyond what the manufacturer originally designed. The project is no longer just about repair. It has become a mission to prove that independent builders can match or even exceed the standards set by major car companies. One of the most interesting parts of this rebuild is the number of upgrades being planned. Instead of simply replacing broken parts, Matt is choosing to redesign and improve them. For example, the exhaust system is being completely reworked. The original system is being removed and sent to specialists who will create a custom version designed to enhance the sound and performance of the engine. The goal is not just to make the car louder, but to give it a deeper and more aggressive tone that better matches the power of the W16 engine. At the same time, custom wheels are being developed using advanced 3D scanning technology. This ensures that the wheels will fit perfectly around the large brake components, where even a small mistake in measurement could cause problems. These upgrades show a clear difference in approach between Bugatti and independent builders like Matt. While Bugatti has to consider regulations, comfort, and a wide range of customers, Matt can focus purely on performance and personal preference. This allows him to push boundaries and explore possibilities that the manufacturer might not offer. As a result, the rebuilt Chiron could end up being not just repaired, but transformed into something unique and even more exciting than the original. The most important part of the story revolves around the damaged gearbox mounting bracket. This component connects the engine to the transmission and plays a crucial role in the car's structure. When Matt examined the damage, he noticed something unusual. The way the issue was identified during the inspection process did not seem random. It appeared as if inspectors were specifically told to check that exact area, even though the main damage was at the front of the car. This raised a key question. Why would they look there unless they already suspected a problem? Matt suggested that Bugatti might have known that this particular part could fail under certain conditions, especially during a crash. If this is true, it means the damage was not completely unexpected. In fact, it could have been a known weak point designed to break in order to protect more expensive or critical components. This idea is not uncommon in engineering, where certain parts are intentionally made to fail first. However, what makes this situation interesting is how it was handled afterward. If the part is replaceable and the failure is predictable, then why was the entire car declared a write-off? This question has become the center of the discussion and has led to many different theories. If Bugatti was aware of this potential failure point, it could have several important implications. First, it suggests that similar failures may have happened in other cars before, meaning this is not an isolated case. Second, it raises questions about the decision to write off the car instead of repairing it. One possible explanation is that allowing such repairs could set a precedent. If insurance companies and repair shops realize that even severely damaged chirons can be fixed, it could affect the value and exclusivity of these cars. Bugatti has always maintained a strong level of control over its vehicles, including how they are repaired and maintained. By limiting access to parts and information, the company ensures that only authorized facilities can work on their cars. However, projects like Matt's challenge that system. They show that skilled independent builders can find their own solutions, even without factory support. This could lead to a shift in how people view high-end car repairs. Instead of relying entirely on manufacturers, more enthusiasts might start exploring alternative methods. While this could be exciting for the community, it also creates tension between manufacturers and independent builders, as both sides have different goals and priorities. As the rebuild continues, Matt is taking things a step further by improving the original design of the gearbox bracket. Using 3D scanning and computer modeling, he is creating a new version of the part that is stronger and more efficient. Unlike the original cast aluminum piece, which has certain limitations due to the manufacturing process, the new version will be made using CNC machining. This allows for more precise control over the shape and thickness of the part, reducing weak points and increasing durability. At the same time, other damaged components like the radiators are being repaired by specialists who believe the work is straightforward. This shows that not every part of the chiron is as complex or exclusive as it might seem. With the right skills and tools, many components can be fixed or recreated. As a result, the project is proving that rebuilding a hypercar outside the factory is not only possible, but also practical in some cases. Looking ahead, Matt has even considered buying the car himself once the rebuild is complete. This shows a high level of confidence in his work and adds a personal element to the story. In the end, this project is about more than just one car. It is about challenging assumptions, exploring new possibilities, and showing what can be achieved with determination and creativity. Another important part of this rebuild story comes from something that might seem less exciting at first, but is actually very revealing: the damaged radiators. In total, 4 radiators were affected in the crash, including the air conditioning condenser. At first glance, many people might assume that these are highly specialized parts that can only be replaced by Bugatti itself. After all, the Chiron is one of the most advanced cars ever built, so it is easy to believe that every component is unique and extremely difficult to repair. However, when Matt Armstrong took these radiators to a specialist, the response was surprisingly simple. The expert looked at the damaged units and explained that, despite their high performance, they are still fundamentally standard radiators in terms of design. Yes, they are built to handle extreme conditions, but the basic principles behind them are the same as many other performance cooling systems. One radiator had a large hole, and another was badly bent, but the specialist was confident that both could be repaired or recreated without major difficulty. The real challenge was not the radiator core itself, but the exact positioning of the mounting points, hoses, and connections. These details need to be precise, so everything fits back into the car perfectly. Even so, the solution was straightforward. Measure the undamaged radiator and replicate those dimensions when rebuilding the damaged ones. This part of the project quietly breaks another myth, that every part of a hypercar is impossible to fix outside the factory. In reality, with the right knowledge and tools, many of these components can be repaired or reproduced by skilled professionals. This discovery adds to the growing idea that the Chiron may not be as unrepairable as people once believed, and that the limits placed on such repairs may be more about control than actual technical barriers. As the project moves forward, it highlights a bigger conflict that goes beyond just one car. On one side, you have large manufacturers like Bugatti, who design, build, and control every aspect of their vehicles. On the other side, you have independent builders like Matt Armstrong, who are proving that it is possible to work outside that system. This creates an interesting tension. Manufacturers often limit access to parts, technical data, and repair processes. They argue that this is necessary to maintain quality, safety, and brand image. From their perspective, a poorly repaired car could damage their reputation. However, independent builders see things differently. They believe that once a car is sold, the owner should have the right to repair or modify it as they choose. Matt's project is a perfect example of this mindset. He is not waiting for permission or relying on official support. Instead, he is finding his own solutions, working with specialists, and using modern technology like 3D scanning and CNC machining. This approach shows that knowledge and skill can sometimes replace access to official resources. It also raises questions about the future of car ownership. If more people follow this path, manufacturers may have to rethink how they handle repairs and support. The balance between control and freedom could shift, leading to new opportunities for builders and enthusiasts. At the same time, it could also create challenges, especially when it comes to safety and standards. This ongoing debate makes the Chiron rebuild more than just a technical project. It becomes part of a larger conversation about the relationship between car makers and the people who buy their products. As the rebuild gets closer to completion, another layer of the story becomes clear: the financial and personal investment involved. This is not just a simple project funded by views or sponsorships. Matt Armstrong is deeply involved in every step, and he is even considering buying the Bugatti Chiron himself once it is fully rebuilt. This decision shows a high level of confidence, but it also comes with significant risk. A car like the Chiron is extremely expensive, not just to buy, but also to maintain. Every part, every repair, and every upgrade adds to the total cost. To make this possible, Matt has talked about selling some of his other cars to raise the necessary funds. This adds a personal dimension to the story, as it shows that he truly believes in the success of the project. He is not just building the car for content, he is investing in it as if it were his own from the start. This level of commitment makes the story more engaging for viewers, as it raises the stakes. If the rebuild succeeds, it will be a huge achievement, both technically and financially. But if something goes wrong, the consequences could be serious. This risk-reward balance is part of what keeps people watching. It turns the rebuild into a real-life challenge, where the outcome is uncertain and every decision matters. It also shows that behind the cameras and the editing, there is a real person making tough choices and taking big risks to achieve something extraordinary. In the end, the rebuild of the Bugatti Chiron is no longer just about fixing a damaged car. It has become a story about discovery, challenge, and change. The finding related to the gearbox mounting bracket has opened the door to many important questions. Did Bugatti already know that this part could fail? If so, why was the car treated as a total loss instead of being repaired? And what does this mean for other cars that may have similar issues? While there are no clear answers yet, the situation has encouraged people to think differently about how these vehicles are designed and managed. At the same time, Matt Armstrong has shown that determination and creativity can push beyond limits that once seemed fixed. By challenging the idea that certain repairs are impossible, he has inspired a new way of thinking in the automotive world. This project is proving that with the right approach, even the most complex machines can be understood, repaired, and improved. As the rebuild continues, many people are watching closely to see what happens next. Will the car perform better than before? Will it change how manufacturers approach repairs in the future? These questions remain unanswered, but one thing is clear: the story has already made an impact. It has turned a single rebuild into a conversation about innovation, independence, and the future of automotive engineering. One of the most exciting parts of this rebuild is the complete transformation of the exhaust system, and it reveals a lot about the difference in philosophy between a global manufacturer and an independent builder. In the original setup of the Bugatti Chiron, the exhaust system is designed with many compromises in mind. Bugatti has to follow strict noise regulations, emissions laws, and customer expectations across different countries. This means the exhaust cannot be as loud or aggressive as the engine is truly capable of sounding. However, for Matt Armstrong, those limits do not apply in the same way. His goal is to unlock the full character of the car's powerful W16 engine. To achieve this, the entire rear exhaust assembly was carefully removed, which required taking apart a large section of the car's rear structure. This alone shows how complex the Chiron is, as even accessing one system can involve removing multiple components. The exhaust is then sent to a specialist company that will scan it and design a custom system from scratch. Instead of simply making it louder with straight pipes, the plan is to engineer a balanced system that improves both sound and performance. The primary catalytic converters will remain to keep emissions within acceptable limits, but the secondary restrictions will be removed to allow better airflow. This approach highlights an important idea. Performance is not just about making things louder or bigger, but about understanding how each part works and improving it in a smart way. If done correctly, the new exhaust will give the Chiron a deeper, more aggressive sound that better matches its extreme performance, while still keeping it usable in real-world conditions. This upgrade alone shows how the rebuild is not just about fixing damage, but about rethinking what the car could have been if fewer compromises were required. Another key factor that makes this rebuild possible is the use of modern technology, especially tools like 3D scanning and computer-aided design. In the past, rebuilding a car as complex as the Bugatti Chiron without factory support would have been nearly impossible. The level of precision required is extremely high, and even a small mistake can lead to major problems. However, today's technology allows independent builders to work with a level of accuracy that was once only available to large manufacturers like Bugatti. For example, the damaged gearbox bracket was scanned in detail to create a digital model. This model can then be studied, modified, and improved before any physical part is made. Engineers can adjust the thickness, shape, and structure of the component to remove weak points and increase strength. Once the design is finalized, it can be produced using CNC machining, which cuts the part from a solid block of material with incredible precision. This process not only improves the quality of the final product, but also reduces the chances of failure in the future. The same technology is being